Hello and welcome. This is Camille Fairborn from Utah State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenters today Dr. Chester Ismay from Reed College and Pacific University, and Dr. Albert Kim from Middlebury College. For today's webinar, they will give a presentation entitled A Fully Customizable Textbook for Introductory Statistics Data Science Courses. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give the presenters a chance to respond. You can also use the chat box if you are having any technical questions. At this point, I'll turn things over to Dr. Ismay. Chester, go ahead.
Well, thanks so much, Camille, and thanks everyone for attending. So I want to tell you just a little bit about myself. I'm an instructional technologist, and I'm kind of the R guy on campus at Reed College. And then I teach social statistics at Pacific University. I guess I'll let Albert talk about himself just a little bit, and then I'll lead into the presentation.
Yes, I am a tenure-track faculty member of the math department at Middlebury College, a small liberal arts college in Vermont. And I teach, among other classes, intro statistics, the 300 level probability and statistics sequence, and data science and machine learning courses.
Yeah, and feel free to jot down our email addresses there. If you have any questions, we're happy to answer after the fact, or go ahead and enter your comments at any time throughout the presentation. Hopefully at the end we'll be able to go over them. You can follow our slides. They're available via that link there, and that link will also be shown at the very end as well. So I want to just kind of hop in and start with why did we create this textbook? Why did we think that this was something that was needed? Well, really how this came about was we wanted a way to encourage students to see statistical analysis and data visualization done in very much the same ways that actual practitioners of modern statistical analysis and data science really kind of do it today. We wanted a free textbook focused on developing algorithmic and computational thinking in students, and then integrate ideas from both a traditional introductory statistics curriculum as well as from kind of the emerging field of data science. So our book kind of has 6 guiding principles that both Albert and I will go through and discuss, and our name, Modern Dive, is really just us taking a modern dive into data. And we're using R, a statistical programming language. We aren't going to talk about that a lot today, but we'll briefly mention that going forward. So I'm going to segue over and let Albert talk about a few of these.
Okay, so we have a list of 6 principles that really, as Chester said, guided the thinking that went into Modern Dive. And the first one I can say kind of starts with an anecdote. I was having my lab section, which was a lab section that occurs on Thursdays for a class that occurs on Monday, Wednesday, Friday. And I noticed that students kept struggling to find outlets. There weren't enough power cords. They were tripping on power cords and all sorts of things like that. And that's when it dawned on me that, oh, wow, all these students are bringing their laptops to class, even though we were in a computer lab that had all these desktop stations in it. So it occurred to me at that moment, if students are already bringing their laptops to lab, why even have the lab there? And then it occurred to me, why not even just have them bring their laptops to lecture? So that is our first principle right there, is this idea of blurring the lines between lecture and lab. Chester? So it sort of dawned on me, and I'm not saying this is a completely true statement, but I think that a lot of people would agree to a certain degree. A lot of people would agree to a certain degree that this idea of a segregated lab and lecture is really a legacy of when desktops reigned. And I mean, laptops weren't a thing, and computing was expensive. And also, expensive proprietary statistical software was usually the best only option. So you needed to have that installed somewhere, so the lab was the place to go. Today, however, almost all students have access to laptops. Now, I'm very careful about my wording there that not all students have laptops, but I think that this is sort of becoming a model where most students in most institutions at least have access, either via the library or loans. And also, open source software options are becoming much more palatable, and these options are free. Thank you. So we thought of it a new classroom environment where we have a textbook that leans on, that is electronic, that students can view on their computer, that they bring in, to lecture, thereby blurring the lines, as I say, between lecture and lab. And also, another thing that I noticed that I did not put in the slides is that why do we have a separate textbook that they read on their own and have class notes on the board? Why not, when it comes to certain topics, why not have the students actually go over the textbook itself in class? Now, this approach is not doesn't work universally well for everything, but for a lot of the topics we cover in this class, I would argue it works pretty darn well. So here's just an example of students that I have working together in groups of 4. They are actually currently going over the textbook and going over in-class exercises. Chester? Here's another example right here. So they have, on the one hand, a browser where they're going over their electronic textbook, and on the other part of their computer screens, they have RStudio open, where they're currently working with exercises directly from the textbook during lecture time.
So I want to shift away from that just a little bit and kind of talk about a really big guiding principle following Hadley Wickham, who's a famous R developer and statistician, who's really done a lot of work on this. We really wanted students to kind of be immersed into the entire research, science, data pipeline. So talking with students about importing data, what does it mean for data to be in a tidy format where the variables correspond to columns in your data set and the observations correspond to rows? That's actually a little bit of a complicated concept for students to understand at the beginning, but getting data in that format really helps out with the understand section, going from transforming your data to visualizing your data to modeling your data, and then finally leading into communication. And communication is a really big driving point of our textbook, and we'll talk about that in our presentation today. I also want to tell you that many of the links or many of the images in this presentation are also links to where we actually got these images or the GIFs. So if you wanted to go use the GIFs, feel free, you can go get them. So data storytelling is a really big part of our course. We really wanted students to be able to tell effective stories with their data, and a big driving force of that is being able to produce really nice data visualizations where within 5 or 10 seconds you get a really good understanding of what you're trying to convey, what message you're trying to say. And another thing we really wanted into the book is really have each topic build on previous topics. So all throughout the course they're doing data visualization, all throughout the textbook they're talking about what tidy data means, how to manipulate your data. All that stuff feeds into inference in kind of the second part of the course. So we kind of see ourselves as a mother robin. The students are really just pining for data. They want the data, so we're figuring out ways to hand the data to students and really kind of scaffold in a nice way. And so we wanted to use really interesting different data sets that students could work with that are as current as possible, while not necessarily being really clean kind of traditional textbook sorts of examples, where they might have to work with missing data just a little bit and kind of understand that in the real world, data is not necessarily clean, it's a little bit messy. And when I talked about this just a little bit, but we wanted data visualization to be the driver. So this is from the Gapminder data set. The Hans Rosling Gapminder folks put together this website, or put together this data, and there's a Gapminder R package that allows students to work with this. And so you can tell lots of really interesting stories based on this nice data visualization, and this is actually pretty easy to produce using R and the ggplot2 package. So we expose students to learning about ggplot2, and it's because it can really easily graph lots of different kinds of things, and it's really powerful in telling a picture in a really easy way. I'll shift over to Albert now.
Okay, so now when it comes to the traditional topics of a statistical inference course, we're very big fans of the simulation / resampling approach. And this dawned on me when I was teaching my theory of statistics class, which is the rebranding of the traditional 300 level class, where I used Professor Chihara's and Tim Hesterberg's textbook, Mathematical Statistics with Resampling in R, where they jump right away in chapter 1 or 2, I believe, with a two-sample permutation test. And I thought, wow, isn't that interesting? Instead of the sort of traditional build-up over random variables and independence and the central limit theorem and then standard errors and sampling distributions, students can investigate and answer questions with data really, really soon. So I thought, why don't we incorporate some of these ideas in the intro-level course? Now, there have been numerous discussions, I think, elsewhere, and I think Cause included, about this sort of resampling and simulation-based approach. So I won't delve too much into that, but I did want to make clear that this is one thing that we are very big fans of, and also because the students are going to be very familiar and well-versed with data visualization, we can complement any theory with a lot of graphics. And I feel that that is really, really good in supplementing students' understanding of very, very nuanced statistical topics. For example, Chester, the ideas of the central limit theorem. I think it's a very nuanced concept. There's a lot of understanding that goes on. So one approach you could take is the approach of, like I said, building up to it from probability theory, or we take a resampling approach where you see the histograms there, and we draw samples and run simulations and study the behavior of point estimates in using that approach. And I think that one also note that we are very, very big on is that ultimately, when it comes to hypothesis testing, there ultimately is only one hypothesis test. Now, the parameter of interest, the setup might differ, but ultimately, really, this is the setup. You have a model for what you think the null hypothesis is. You have simulated data. You compute a test statistic, and you compare that compute the observed test statistic, and you compare that to the simulated test statistic. And I think that by really using simulation, students can understand the general idea of what an observed statistic and a p-value is, and then study all the specific kinds of hypothesis tests that they might encounter in their future careers as case-by-case examples. The next point we want to make is this whole idea of fencing off the students from the computational pool or not. Now, we've had lots of discussions with a lot of our peers about how much do we lean on matters of programming, of algorithmic thinking, and coding. Some people feel that this is not within the purview of a statistics course. We, however, think that, no, this is a very, very important component of how statistics is done and will be done in the future. And thereby to shield students from any notion of computation and programming is to do them a bit of a disservice. Now that is easier said than done. It is really, really important, especially for complete novices who have never seen programming and only used point-and-click software, that we scaffold and support all the topics we learn, much like a good foreign language professor would. So what I mean by scaffolding and support, well, obviously providing good tools, but also providing them the emotional support. So for example, I constantly remind my students that learning to code is like learning a foreign language. It is very, very difficult at first. But if you keep pressing and keep working at it, you will get better. And second, another strategy that I use is to remind students that, you know what, computers are actually stupid. A lot of students are used to smartphones and very advanced technology that seem really intelligent, but they're only really intelligent because an engineer put a lot of work into making it seem very, very smart. But no, computers are actually stupid. You need to tell it everything it has to do right up until the having parentheses match. But I think the bigger issue that we're trying to address here is that we believe that coding and algorithmic thinking and computational logic will soon be a basic skill on par with reading and writing. So beyond just the world of statistics and data science, for almost any field, this will be a basic skill set on par with reading and writing. And we need to not fear computation.
So what we really want here is we also want to really feed in with all of the ideas that Albert just talked about, and we also wanted to make sure to have our entire source code available for anybody to go out and do anything that they want with our textbook. So this came about as we were working through textbooks, and we found different kind of examples that talked about something that was really interesting in terms of a hypothesis test or in terms of a confidence interval, and we wanted to actually get at the data that was presented in that example, and that data was nowhere to be found. Or we saw a really nice visual that had a lot of different kinds of things in it, but we just wanted to tweak one thing, and that code was not available in any way. So we want complete reproducibility with our book. So all of our source code is available. There'll be links at the very end. And so we just decided to put all of our stuff out there. And we're open to any criticism, any sort of feedback that anyone has with our book. It's all right there, and we want people to go out and go ahead and provide us with feedback. And we really kind of see this as a potential shift in a paradigm shift for textbooks. And so this shift is really, I think, beneficial to both instructors and students, and kind of a crowdsourcing idea and making sure the textbooks are good and valid, and that lots of feedback has gone into them. And we really want to allow others to review our work, and potentially we're saying it's a good idea for you to also follow the same sort of mindset, the same sort of paradigm, by allowing your stuff to be out there and let people go ahead and see it and open yourself up to criticism. And ultimately, we believe that everybody should be writing their own textbooks. You know your students best. You are the subject matter expert. You're teaching biostatistics, or you're teaching psychological statistics or introductory statistics, and you know what is best for your students. So we're just trying to provide a guide to potentially taking the ideas that we have presented and doing whatever you want with them, and just ultimately writing your own kind of textbook based on what we presented. And so I'm not going to talk a ton about this, but what we used was this package called Bookdown. And what Bookdown allows you to do is really easily write a textbook and sync it all together while just writing your code using our code and using Markdown or R Markdown. So both of these links, anything really that's in pink is a link to something else if it's not just an image. So that link to R right there goes to the R Markdown web page. So R Markdown, if you're not if you've never heard of it before, it's a way to write really simple Markdown code and then embed your R code inside there and produce HTML documents, produce PDF documents. It's a really nice way for students to turn in homework. And then Markdown is a really easy text-based tool for bolding your text, for creating lists really simply without doing anything in LaTeX or anything like that. So merging both of those things together, and then Bookdown, what it allows you to do is cross-reference from one chapter to another. Each chapter represents its own R Markdown document. And then what this entire package just allows you to do is make a potential change to a textbook right on the fly. So Camille just yesterday found a typo in our book, and she made a little issue on GitHub, and we went and were able to fix that typo really easily. So it's very easily updatable, allows you to rapidly iterate as you need to. You can export the book to PDF or to HTML like the book is currently formatted. You can have really easy, slick cross-references. And then we really think the big paradigm shift here is we don't want to have our textbook be version 1, version 2. We want our textbook to have versions, not editions. So not edition 1, not edition 2. We want version 0.1. We want version 1.2. Much more of like a software development cycle. So versions, not editions. And then the last thing I talked about before, we really want a Wikipedia model. Wikipedia has really thrived on people providing input, and we think that the statistics community can thrive in much the same way. And kind of in an inception style here, the author of the Bookdown package has written a Bookdown book about writing with Bookdown. So that is a link to that book, and that's how both Albert and I learned a lot about Bookdown. We're able to put our stuff together and have it available for free online via that great Bookdown package. So you saw this in the links to our abstract for this presentation, but our textbook is available for free at moderndive.com and moderndive.org. If you prefer to go to either one, it sends you to the same page. And what we're really pushing for here is the authors are Chester, me, Albert, the other presenter, and potentially you. So if you really like this, we want to work with you and help you try to adapt this to your needs. And so we're really starting this different way of thinking about textbooks. We want you to be able to take what we've done and add to it and add yourself as an author. So we have just a few tips to kind of think about here as you're potentially thinking about doing something like this. Our biggest thing that we've kind of drilled on today is we really see intro stats and just teaching intro stats changing so much right now. I think even since 2013 when I finished my PhD, introductory statistics is really trying to hop on to data science. And so we're really trying to figure out a new way to do these sorts of things. And we're trying to help you and encourage you to stay ahead of the curve and really be on the cutting edge as much as possible with your introductory statistics courses. And this is a little bit funny that we're saying we're trying to be on the cutting edge, but we also use a lot of the chalkboard and whiteboard still in our classes. So we're not just exclusively writing code all class period in the computer. We're also going up to the chalkboard and writing the code down, talking about where there's a potential issue or where you missed something, or if we want to draw just a very basic plot and potentially color by another variable. We're doing those sorts of things on the chalkboard to engage with the students and have them understand the theory. And then also in addition, just like Albert said at the very beginning, we're merging lecture and lab. So in addition to doing these things where we're talking about the theory, we're applying that with our code and asking the students to either engineer the code to design a plot or to potentially write the code to reverse engineer a plot as well. And maybe the best tip we can tell you is don't think that you have to just completely change your entire curriculum right now. I really highly recommend this book by James Lang. He is an English professor, but it really talks about lots of little tiny things that you can do in your class to really help students learn ways. And so we kind of follow the same model here. Add just a few of the things that we've talked about into your course, and that can really help your students. So just add in a little bit of the data that we potentially present, or add in, have the students read maybe a 538 article that we reference, or something like that. So just add in little small pieces. Have the students bring their laptops every other class period instead of just going to the labs once a week, and kind of see how it goes and adapt as you need to. But really start small. Don't think you have to change everything all at once like we did. So this is nearing the end of our slides. I do have, if you kind of click through the slides already, there's a lot of supplementary materials at the end we'd be happy to talk about, but we really want to try to answer as many questions as we can in the time allotted. And so we'd really love for you to join us. We're leading a workshop for a day and a half at US COTS at Penn State, 17th, and we're really going to kind of dive into a lot more stuff there with R and show you how to use the Bookdown package, show you how you could potentially take your lecture notes and add them into a book and put them up on GitHub and do all those sorts of things. If you would like to get more updates about our textbook, please fill out the form that is linked there via MailChimp. Those are our email addresses there again. And then please do follow us on Twitter. We try to tweet out about statistics, interesting kind of open data sorts of things, and we'd be happy to add you as we potentially be happy to follow you as well if you have really interesting kind of things going on. And we were happy to open it up for questions now, if that's okay.
Yeah, we've got a few questions so far. First of all, Nicholas Horton wanted to thank you for renaming mathematical statistics to theory of statistics, so he's a fan of that. Craig Whippo is asking, what is your assessment approach with this textbook?
Albert, do you want to
Chester? I'll take that one. I'll take that one. So the assessment approach is we do it daily because we believe that instead of having the students just start the assignments the night before, we have at the end of every day we have these modules, and at the end of each module we have things called learning checks. Now you can argue if isn't that just a semantic rebranding of review questions, but we but what it ultimately a learning check is that it sort of goes over questions that it goes over the topic just covered in class, and we dedicate, both of us, time in lecture for students to do this because the students are there with each other. So a big part of this, our model of teaching is how do we leverage the fact that everybody's in the room together. So that's why the typical model is that we only maybe talk and lecture for about 10-15 minutes to prime discussion, but then we have the students read the book at their own pace and then work on the learning checks at their own pace. Now, I believe Chester collects the learning checks, whereas I say, you know what, I say, you know what, no, you're going to self-police yourselves because these learning checks are ultimately going to build in to the problem sets and the exams. So my exams are very much built off of learning checks. But so you can collect these things, you can not collect these things, but I think the key component is that we have learning checks and we give students time to work on these while they're with each other in the lecture room. Is there anything you want to add to that, Chester?
Yeah, what I've started doing the last couple semesters is I also have projects, and so students are analyzing data in groups using R and RStudio. And this semester, if you go ahead in our slides just a little bit here, we also worked on a 538 R package. So this has a lot of the data sets that 538 has used in their actual analyses. They published to GitHub, and we've worked with them on adding those things into our courses. And so students analyze data sets from 538, and they try to provide new analysis and new kind of insights into different data sets that 538 has presented on. I also have multiple choice quizzes, kind of cumulative in nature, 5 times a semester. And so one thing I do is I have students, each student submit 5 multiple choice questions, and then that creates a big pool of questions that I pull kind of a subset from, and then I tell the students, you know, of the 30 questions I chose, I'll pick 10 of those questions to be questions that you'll have for your quiz. And so this provides a really nice way for students to see the other kinds of things that students potentially struggle with. It provides great data on lots of different types of questions that I could potentially ask students. And I think it's really nice that it gives students a way to both study R and the statistical concepts that we're covering in class and make sure that they understand how they both relate. So it's not just an R course. I think Albert and I can both say that we cover the exact same material that is covered in a traditional introductory statistics class, but we also teach them how to use R, and we see that skill as just being an immense skill that they can take from stats, as well as learning what statistical content is and what statistical ideas kind of convey.
That's great. Another question, what backgrounds do your introductory students have? Are they mix of majors, STEM, non-STEM? How does that affect your course content?
Sure, I'll start off with that. So I have students really kind of from all over the place. It's a social statistics class at Pacific University. So at Pacific, there is a math requirement. So students can take calculus, or they can take stats from the math department. They can take stats from the psychology department, or they can take stats from the sociology department. I tend to have a lot of students in criminal justice, political science, sociology, so it's much more of a social statistics class. Our textbook is based on more of a general kind of statistics, so we don't have any specific examples about or have the entire textbook written about social statistics. It's much more general focused, but all of our assignments, and we're also working on a data camp course, so that's another supplementary material here. This is much more focused on these 538 data sets. And so what I also do for homework is I have students work on these different 538 data sets inside this little data camp course. So this could essentially be its own little webinar, I think, but this provides a nice way for students to write code in R and get immediate feedback. And we've really liked it so far. And we also have links to our course web pages here if you want to kind of see what other kinds of things we've done and how we incorporate these things into the class.
Yes, and in my case, it's very much the kind of the service class model where we have students from all over campus take this class. So just going over the list of majors, I have biology / studio art, Chinese, econ, environmental policy, geography, history, molecular biology. It's really a wide array of students. And I think one key thing to, and a wide array of years, because a lot of students will wait until the very, very end of their undergraduate careers to take stats. But I think one key thing to note is that there is no programming prerequisite for this class. Now, I tell students, there are some students from CS who come in with a Python background. I tell them, you know what? This class is not pitched at you. This is a class pitched as somebody who has never programmed a lick in their life. So I think it's really, I try to keep things pitched to a very, very broad base. and I think that's the reality given the broad array of majors and years that of students that populate my class.
All right, one more question. Do the students have access to the code for your learning checks from the GitHub? So I guess is that saying is your homework on GitHub that they can just go and look at it that way?
Okay, so when it comes to the actual, so we after we have assign a learning check, let's say on a Wednesday, in the following lecture, say a Friday, we'll post what we call discussion points. Now, we're very careful about the terminology and that we don't call them solutions because solutions suggest that there is a right answer. So yes, we provide them in a subsequent lecture with code and everything to answer that that could be one approach to answering these learning check questions. But as far as the material is concerned, yes, it's all accessible online. So for example, exam questions, no, we would not put that in the same directory.
Well, all right. Are there, I think we've come to the end of the questions. Thank you so much for presenting this today and looking forward to seeing what you do in the future at USCOTS and beyond. To those of you who are attending, please keep your eye on announcements from CosWebs about future webinars, and we'll hope to see you all next time. Thank you, Chester and Albert, once again.
Well, thanks everyone. Thanks, Camille.